Okay, guys, welcome back. This is question number 34. And you guys see there's a wire, and there's a current going through that wire. So we're gonna use the linear density to prove certain electric field and magnetic field on that field that is going through that wire. So question number A, we need to find what's the electric field and the magnetic field at a point of the loop by the scientist in the lab. So by the reference frame of the scientist in the lab, and including both strength and direction. Okay, for this one, we know that the magnetic field in the wire is at rest on the reference frame in the laboratory. So in the scientist reference frame, the wire is at rest, meaning the magnetic field is 0. But we know that there's an electric field because there's a current going through it. So on the linear density of the wire, we can use the formula of the linear density 2 divided by pi constant distance from the distance or from the center of that distance of linear density. This is what we know for question number A from this reference frame of the scientist in the laboratory. Question number B, what are the electric field and the magnetic field at a point and on the loop as measured by scientists in the frame of the loop? So now it's a different story. Now we know in the loop, reference frame on the loop, there is an electric field and there is a magnetic field. So on the loop frame, the electric field will be equal to the density divided by 2 pi electric constant actually there's no constant. There's no constant. So the electric field near this. Let me check something first. Electric field near city. Okay, so we know that there is an electric field, and that's exactly the linear density divided by 2 pi constant multiplied by the distance and from the radius and the distance divided by their radius. And hold on, let me try something else. Actually, they used the reference frame from the loop of the electric field, and that's electric field plus the speed multiplied by the magnetic field. Magnetic field equals 0, so electric field frame equal to the electric field equal to the linear density divided by 2 pi constant multiplied by the radius divided by the radius multiplied by the distance from the center. This is for electric field. From the magnetic field frame of the loop is equal to magnetic field map divided by c square multiplied by the speed and multiplied by the electric field. As we know, the magnetic field is 0 minus 1 c square multiplied by the speed multiplied by the linear density divided by 2 pi constants divided by the radius multiplied by the distance, and this one will give us a reference frame from the of the loop. Linear density multiplied by the speed divided by c squared 2 pi constant divided by the radius multiplied by the distance. So this is for question number B. Question number C. So we have to prove that the current is equal to linear density multiplied by the speed. We know from previous classes that the current is equal the charge divided by the distance, and we know that the speed is equal distance divided by time. So this is how we can prove that the current is equal to the linear density multiplied by speed. Okay. Question number D. What electric field magnet would an experiment in the loop frame calculate distance r from the current of part C? So if somebody wants to measure the electric field on the wire, if there is no movement, there is no current, meaning no electric field. That's from the reference frame of the experimenter in the loop. But there will be an effect. But magnetic field will be affected. Not affected. But the measure will be measured. Will be measured. That means the magnetic field is equal minus the linear density multiplied by the speed divided by 2 pi constant c square divided by the radius multiply by the distance. Question number E. Show that your field of part B and D are the same. Okay, so part B is, hold on, let me put it this way. Part B is minus linear density multiplied by the speed divided by 2 pi constant c square multiplied by the radius divided by the radius multiplied by the distance. Out, right? So here we know that current is equal to a linear density multiply by the speed. And we know that c square, that's the speed of light. The speed of light is equal 1 divided by the constant. So the magnetic field will be equal to currents divided by 2 pi e square r. A radius divided by the radius multiplied by the distance, then the c square is going to be equal to 1 over 1 divided by the constant. So at the end, the magnetic field will give us the usual formula. Okay, guys, there's one more thing. For the constant, remove the constant in the equations. That's mean there's no constant here. No constant here. No constant here. Yeah.